booster. So quotient rule. We've got where we got two functions of x, one divided by the other. We use the quotient rule, which is this formula over here, and again that will be available to you in the back of the exam paper as a formula sheet. Okay, but again there's a method, split method. We say let u equal the numerator, and it must be the numerator, for sine 5x. Let v equal the denominator, 5x to the 4. And we have to differentiate the two. So du by dx on this side, dv by dx on the opposite side. So if I differentiate 4 sine 5x, I get it's part of my first deliberate mistake of the morning, Lewis. 20 cos 5x, and differentiating 5x to the 4, we get, remember the method, multiply by the index, 4 times 5 is 20, and take 1 off the index. Yeah, that's the ax to the n. Alright, then now we've got, have we got everything for the formula? We've got v, we've got a u, we've got a du by dx, we've got a dv by dx, and we can do v squared. So we've just got to enter all those values into the formula for the quotient rule. dy by dx is equal to v, which is 5x to the 4. Remember, it's worthwhile putting each term in brackets to start with. Multiplied by du by dx, 20 cos 5x. Take away u, 4 sine 5x, multiplied by dv by dx, 20x to the power 3, all over v squared. dy by dx. Look at any kind of simplification here. First of all, that denominator. How can we simplify that denominator? That's not multiplied by 2, raised to the power of 2. Isn't it? It's 5 to the power 2 times x to the power 4 to the power of 2. So it's 5 squared is 25. X to the 2 times 4, which is 8. Yeah, laws of indices. X to the n to the power of m is x to the n times m. That's the law. Yeah. What can we bring together on that top line? we've got two constants here. Yeah, so we can make that 100 x to the 4 cos 5x and we've got two constants here too. Minus 80 sine 5x times x to the 3. Sorry? Well, you can put it that way round. If you prefer it. 80 x to the 3 sine 5x. Any further? Sorry? It's a common term. Remember, you're looking for common term either side of that minus sign. Where do you get 5x cubed? 20 x cubed. What's wrong with that? Yeah. Back, getting 20 back from 100 is 5x cos 5x minus 4 sine 5x all over 25 x to the 8. If you're using that or that to get a result, you'll get the same result if you plug in a number in for x. But ultimately that is the simplest form. Okay. On the next page there's a couple of use of quotient rule for you to have a go at. I'll give you 5 minutes to have a go at the first one and see how you get on. See if you get the result given. We have a situation where we've got a function of x, 5x squared plus 2, all inside another function of x, which is the cosine of x. It's all multiplied by 3 as well. Function of a function. We need to use the chain rule, and this is the formula. Again, there's a method. First thing we do is let u equal 5x squared plus 2. The bit inside the brackets. What we can then do is say y is equal to 3 times the cosine of u. So we've taken that formula and we've replaced 5x squared with u. The u by dx, so differentiate this, do what I usually do. Split the board. Du by dx, so differentiating here, what do I end up with? 10x constants, lose it, yeah. dy by du, yeah, minus 3 sine u using the table. Now, have I got everything I need for the formula? dy by du, du by dx, yes. So we enter those values into the formula. So we can go dy by dx is equal to, and the formula says dy by du minus 3 times the sine of u multiplied by du by dx, 10x. Simplify, minus 3 and 10 is minus 30 x times the sine of u, and the last thing we do is replace u with the function we called u in the first place. So equals minus 30 x sine brackets 5x squared plus 2. Yep. Just take a look. All happy with that? Yeah. There's a method. This first one here, if that was 2x minus 1 squared, we might decide to just multiply out the two pairs of brackets into one term and then differentiate. But we're not going to multiply out 6 bracketed terms of 2x minus 1. We'll fill the board or our piece of paper with a mess. We'll do is use the chain rule where letting u is equal to 2x minus 1. So have a go at that top one at least and see if you can get a result for that. Okay? I'll put the final results on the board so you know what you're aiming for. So practical uses. A number of uses in engineering. For instance, determinant rates of change. How fast one variable is changing as another one changes. Rate of change for position. Velocity and acceleration problems. They're rates of change problems, effectively, of a particular type. Newton's laws of motion equations and that type of thing. Okay, speed, velocity. Zero. Okay, so we can do that. And practical problems involving minimum and maximum values. So maybe a projectile question, throw a ball up in the air, how high does it go? That kind of problem we can do. Using differentiation, find the minimum and maximum. So, rates of change. If a quantity y depends and varies with another quantity x, then the rate of change of y with respect to x is dy by dx. That's what you're doing when you find dy by dx. You're finding the rate of change of y with the change in x. So how fast does y change when x changes a certain amount? Okay. We could have the rate of change of pressure with respect to height, dp by dh, if p is pressure and h is height. Have the rate of change with a rate of change with respect to time is usually just called the rate of change. So time is assumed there. A rate of change of current, I, is di by dt. So current changes over time, di by dt. Rate of change of temperature, d theta by dt, for instance. And they're just examples. Okay, so they're not always going to be, when we start to bring in a practical problem, they're not always going to be dy by dx. Okay, but the methods remain the same. So, the length L meters. So, length of a certain metal rod at temperature theta degrees C is given by L is equal to 1 times that very small number plus another very small number squared. Okay, so we got L is equal to 1 plus 0.405 theta plus 0.60 theta squared degrees C. The other point to remember, once we bring in an engineering problem, is we may or may not bring in the involvement of units, and therefore the units will be a required element in your answer. You'll drop marks if you don't include the units when they are relevant. It says determine the rate of change of length in millimeters per degree C when the temperature is A 100 degrees C and B 400 degrees C. So the first thing we've got to do is find the rate of change is equal to dL by dt. So we've got to differentiate that function. Have I missed something off? 4 on the end of there. Well spotted. My deliberate mistake, Andrew. Only ever make deliberate ones. Alright? For you to spot. So we've got to differentiate that. The 1 becomes constants. When we differentiate, disappear. Differentiate that small number times theta becomes just the number. The variable disappears. Plus, we've got to multiply by 2, so it's 0.608 theta. Yeah. And now we just plug in at theta equals 100 degrees C, dL by d theta is equal to 0.5 plus 0.000 times 100 equals meters per degree C, because the length was in meters, change in length is in meters, initial definition, equals 0.13 millimeters per degree C. So we just differentiate and then to find the rate of change at a given point, substitute in the value. And at 400 degrees C, okay? So find the rate of change, and then if we want to know what that rate of change, find the differential, which is the rate of change. So we differentiate and then plug in the values to find the value of that slope or differential at a given point. The displacement S centimeters of the end of a stiff spring at time t seconds is given by S is equal to A e to the minus kt we want the b. So if we have a function for position, we differentiate it, find the rate of change of position or velocity. More about that, detail about that in a minute. So we need to do find that involve us doing here. Product rule. Yeah, we've got a function of x, a times e to the minus kt, the t, sorry, we've got sine 2 pi f. So have a go at that, see if you can get an answer. For anyone watching the video, the result is going to be on the second part.